This is question number 2 on the extra quiz review practice that I posted for our solution stoichiometry quiz, our first big quiz of the year. So we're going to do the same thing. We'll talk about the question. I'll talk about my intention, like when I wrote the question, sort of like what I was thinking about, like what I'm trying to get at, and then we'll walk through the solutions together. Okay. So another precipitation reaction. We got 100 milliliters of 0.2 molar magnesium chloride solution, and we're going to mix that with a small amount of 0.2 molar potassium hydroxide solution. We'll get a white precipitate with a mass of 0.42 grams. That forms. We're going to take that out of the solution, dry it, weigh it, do all that stuff. Okay. So we want to start by writing our net ionic equation. And that is usually our first step of any of these calculations I ask you on a quiz or a test, as I'm going to ask you for the chemical equation, most of the time the net ionic. Now you've got your solubility rules, right? Like you could do the whole thing. But I hope that you're getting somewhat comfortable with thinking about what the products are, right, of these double displacement reactions and what's actually going to precipitate. So if I'm looking at this, I see that we've got a potassium cation and a magnesium cation. I know that potassium never precipitates. There is not a potassium salt that would precipitate under normal conditions. Okay, so that means that it must be magnesium that's coming out, and it must be magnesium hydroxide, right? Because magnesium is initially with chloride. It's going to double displace and go with hydroxide. Now, if it's helpful to write the whole thing out, please do that. But know that, we can kind of like do our, put our thinking cap on, do a little problem solving and figure that out. So I'm actually going to work into this net ionic backwards. And I've showed a few people this, but this is magnesium hydroxide. Magnesium's got a +2 charge. Hydroxide's got a -1. So I know that's going to be MgOH2. And then I'm just going to ask myself, like, what do I need to make magnesium hydroxide? Well, I need 2 hydroxides, right, because it's OH2. And I need a magnesium. And look at that. We just wrote our net ionic, right? So we're kind of like reverse engineering this net ionic equation, which you are totally welcome to do, and I think in some cases is going to be advantageous for you. All right. We got our net ionic, and we're going to go forward, and we're going to talk about the other parts to this question. This is another one where, we kind of like broken it up. I'm asking you questions, so you have to think about like, how do I arrive at that number, right? That's the skills we're building here. We're building our critical thinking skills. So let's slide over. Let's look at part B, and then we'll go look at part C and D. All right, so here we go. Part B. So there's our net ionic that we just wrote. Part B says what volume of 0.2 molar potassium hydroxide solution was added to form the 0.42 grams of precipitate. So we write our net ionic. We know that our precipitate is magnesium hydroxide. Okay, there it is. So again, we're using part A to do part B, right? We got to build that skill. We got to build the skill of like taking this answer, moving it down, doing the second thing. So I'm going to convert that to moles. Here's the molar mass of magnesium hydroxide. 0.00720 moles MgOH2. All right. I got to get back to potassium hydroxide. I want to know how many moles of KOH we used here. So magnesium hydroxide and potassium hydroxide have the hydroxide in common. Right? That's our shared ion here, the OH. So I can use that ratio because I know that the OH in the magnesium hydroxide had to come from the KOH, right? That was the only source. So we had to get it from there. So the idea is that we've got the moles of MgOH. How many moles of hydroxide is that? It's a 2-to-1 ratio, right? 2 OHs. And then 1-to-1 with KOH. Because I know all of this that I've highlighted in blue here is all of this, right? It had to come from there. So we're just working backwards to that. All right. So moles of MgOH. 2 hydroxide per MgOH2, 1-to-1 with KOH, 0.0144 moles of KOH. Right? We're asked for the volume, so we're going back to our molarity equation. Molarity equals moles over liters. We're given the molarity in the problem. We just found our number of moles. We're going to solve for liters. You do moles over molarity. Now, I mentioned in another video Where can I squeeze this in here? We'll go to the top here. I see some people getting tripped up on that algebra, right? On that rearrangement. So don't shy away from the triangle, right? Here's our triangle. I got to solve for liters. We're to cover liters up in that triangle. Let's cover it up. Boop, there it is. How do we get that? We do moles over molarity. Moles over molarity. So to get this number, I did 0.0144 divided by 0.2. That gives me 0.072 liters. I ran it for 2 sig figs because I had 2 sig figs in the problem. You could express that in milliliters if you wanted to. That's also fine. I left it in liters. All right. So there's part B. Let's go forward and we'll look at part C and D. Part C says based on your answer to part B. Ooh, again, there's that idea, right? We did part B. Now we're going to use part B to do part C. We're going to calculate the concentration of magnesium and hydroxide ions in solution after the precipitate formed. Oh, another classic what's left in solution question. All right, so first, our total volume, right? That's where our answer to part B comes from. So 100 milliliters was prescribed in the problem, right? That's our magnesium chloride. And the second part, I calculated that we had 72 milliliters of that potassium hydroxide solution. So we add those together, we get 172 milliliters. Now, again, this is all air carry forward. So let's say on the quiz that you got this wrong, right? And maybe you had, I don't know, like 272 milliliters here. You could still get full credit for this problem, right? Because if this was your answer to part B, then, right, like it's air carry forward as long as you're doing the right steps. So don't worry about stuff like that. I got you. All right, how are we going to figure out how much magnesium is left in solution? Well, again, our moles that remain is moles that we initially had minus moles precipitated, right? You can see moles initially, this comes from volume times concentration, minus moles precipitated, right? So we've talked about how we can do all of those calculations of like what's left over in solution. We can do all of those by like doing that initial minus precipitated. Now, I already had this number up there in my part B answers, right? It's as magnesium hydroxide, MgOH2, but it's a 1-to-1 magnesium to magnesium hydroxide. So I'm just using the same number of moles there, right? We subtract, get 0.0128, put that over the number of liters, which we decided was 172 milliliters, and then we get our concentration of magnesium, 0.0744. All right. Now, the concentration of hydroxide. This is a much easier calculation. And we're going to use some clues from the problem to figure out that hydroxide was limiting. So I've talked a lot about the word excess in these problems, right? We add excess of this solution. Excess of this solution was added, right? And like what that means. Note in this problem, I make a point to say it is a small amount of potassium hydroxide. What I'm trying to clue you in is the idea that potassium hydroxide, and specifically the hydroxide, is limiting. So when I say small amount, that is not excess, right? That's actually the opposite of excess. Small amount means that this is the limiting reactant, okay? Now, let's say you didn't pick up on that, right? Let's say that I wasn't being direct enough and I didn't write the question well enough and you didn't pick up on that. That's okay. You did calculate how much potassium hydroxide was added. You did that in part B. It was 72 milliliters. So you could do a full-on stoichiometry problem here, right? Where you do moles of KOH to moles of MgOH2 and then moles of magnesium chloride to moles of MgOH2, right? And then you could compare. And you would see that the KOH gives you fewer number of moles of product. So that means that it must be limiting, right? You could go the long way and get there, and that is fine. If you want to do the long way, that's fine. I don't think it's so time intensive that like you won't finish the quiz question or you won't finish a test question, right? I'm showing us these shortcuts because I want us to build a level of comfort with these problems, but I don't mean to make the shortcuts mandatory, right? You can get to the same place by like doing the math, right? If you need the proof, do the calculation. If you're curious about that, ask me. I'm not going to show it in the video, but I'm happy to walk through it with you. Okay, so we know that hydroxide was limiting, so that, of course, that means its concentration is 0, all of it precipitated. All right, and then lastly, we're going to add excess potassium hydroxide to that remaining solution, right? So potassium hydroxide was limiting, we're going to make it not limiting. We're going to dump a whole bunch in there. What mass of precipitate do we expect to form? Well, we got to figure out how many moles of magnesium remained, because again, we're making magnesium hydroxide. I already have that here. I did that in part C, right? So it's just the idea of like bringing this number down. That's what's left over, what's available in solution to react. So there it is. I'm just using my net ionic ratio, 1 MgOH2 to 1 Mg, right? It's just back to that equation, and then convert that to grams. I didn't show the molar mass calculation, but we'll convert that back to grams, 0.747. Right, so there's some magnesium left over. We can still get it out. We can still precipitate it by adding excess potassium hydroxide, and specifically we could make 0.747 grams of magnesium hydroxide on the back end. All right, hope that was helpful. If not, you know how to reach me. Send me an email. Come see me. Happy to talk about these.